thing. Independent versus mutually exclusive. So for the following examples, determine if the two events are independent or not, and or mutually exclusive or not. So, select one card from a standard deck and define the events. A, the card is red. B, the card is a club. So discuss with your person next to you for a second. Laura, talk to Candace, maybe.
Okay. Yeah, you can have one.
No, but can a club?
Are we just doing one?
We'll just do one for now.
Yeah, because we read.
Yeah,
so
so
that's
that's
mutually exclusive. What?
Cards.
Oh, it
Yeah. There's four stars. Yes, you're right.
You should know basic card information.
What if you don't know basic cards?
Then you should
Russia.
find a video.
Good. Or you do that point on.
Okay, so mutually exclusive. What's the question I'm asking?
Can you pick up a card that is a club and is red?
Can I pick a red club?
No.
No. Okay, what are the red suits?
Diamonds and hearts.
Diamonds and hearts. So the black suits are
Spades and clubs.
clubs and spades, okay? So, no, I cannot pick a red club. So, is it mutually exclusive, yes or no?
Yes.
Yes. Okay, so if it can't happen at the same time, it's mutually exclusive, right? If in your Venn diagrams they would be in totally different circles, they're mutually exclusive.
What did you say?
These are me.
Oh. You know what I mean.
And it's just all chocolate.
Yeah.
Okay, so if we want to think about independent, okay, so what's the probability that I pick what was A red card?
Yes.
No, what's the probability?
12 out of 52? Wait,
No,
16.
Whatever 52.
26.
Sorry.
26 out of 52, which is 1/2 or 0.5, right?
We need to play
some
more
cards.
I guess we do.
We should have an activity period where we just play cards.
Please.
Before the EP, can we like review all these basic things we should know if we don't know?
Yeah.
Go to the casino.
Things you mean to know. Like 15
Things you
cards.
mean to know.
Well, I'll be 18.
Did you win that?
Oh, I see.
No, I won't.
No. It's when I bought a lottery ticket over the weekend.
Did you win?
Well, I don't know. The drawings are tomorrow.
Oh, that's exciting.
What's the probability that you will win?
I was gonna say, what's the probability that Caitlin shows up to school now?
I'm rich.
Okay, if I want to know if these things are independent, I want to think about, okay, what's the probability that I pick a red card given that I picked a club?
26 out of 51.
No, okay, given that it's a club. I pick a card, it's given that it's a club.
0.
0. Right?
It's not possible.
So, because the probability of A does not equal the probability of A given B, the events are not independent. Okay, so that's how you would like formally write up whether or not it's independent. So you could just think about it like, okay, what's the probability that I pick a club and then a red card, and you can't just multiply by the probability of clubs times the probability of red cards, because once you've picked one card, it's out of the deck of 52, but how would you write that up, like, concisely and intelligently and, in a way that, would make sense to somebody reading it? It's just going to be way easier to do this. So remember, if the two events are independent, the probability of A is going to be the same as the probability of A given that B has already happened. Okay? The fact that B happened doesn't have any impact on the probability of A occurring. if this was true, you would need to also check the other way. Since it's not true, I mean, I don't have any more room, so you don't have to do both, okay? Does that make sense? Okay. Select one card from a standard deck and define the events A, the card is red, and B, the card is a 7. So, mutually exclusive.
No. No, it's not, because a card can.
Independent.
Okay, well, let's do mutually exclusive first. Okay, mutually exclusive first. Are these mutually exclusive? Can you pick a red 7?
Yes.
Yes, so they're not mutually exclusive. Not mutually exclusive because I can pick a red 7.
Because you can't pick the red.
Okay, so the first one, the events were mutually exclusive because there's no red clubs. This one, the events aren't mutually exclusive because I can have a red 7, right? Yeah? Okay. Independent. Okay, probability of A, again, A was what? A red card, so it's still 1/2, right?
Mm-hmm.
Okay? The probability of A given B. So, again, B is that I picked a 7, right? So I picked a 7. How many 7s are there?
4.
4 of them.
But only 2.
Of those 4, how many are red? 2. Okay, which simplifies to 1/2.
Oh.
Okay, so this one checks out. Okay, but again, if it checks out, you have to do the other way as well. So then I need to check to see if the probability of B is the same thing as the probability of B given A. So you have to do both if one of them is equal. Okay, so what's the probability of B? So B again is the card is a 7. So how many 7s are there?
1 out of 4.
4.
4.
4 7s out of
Sorry.
52. That's okay. So that's what, 1/13? One,
Yeah.
yeah,
Yeah.
1/13. Okay. The probability of B given A. So again, given A. So A is there. It's a red card. How many red cards are there?
26.
26. 26 red cards, right? That's my A. Now, of those 26 red cards, how many of them are 7s? 2, which simplifies to 1/13. So that one works as well. So since the probability of A is equal to the probability of A given B, and the probability of B is the same thing as the probability of B given A, then they are independent. Okay?
So you just have to do it both ways.
So you have, if one of them is yes, then you have to do the other one. And again, the way, if they ask you whether or not events are independent, this is what you would do. You wouldn't like try to write this in words like, well, if I pick a 7 and then I'm going to probably, no, just do this, okay? And then like, so this would be a good thing to put on like your little cheat sheet for the chapter, right? As you are thinking about things in this chapter that are important that you want to remember and review for the AP exam. Yeah. Okay. And the last one, 3, says select one card from a standard deck and define the events A, the card is red, B, the card is a heart. You do this right now real quick with a friend. You tell me yes or no for both mutually independent and, sorry, mutually exclusive and independent.
Yeah.
Wait,
Doesn't it have to happen?
Yeah. Why? It's neither. Because all Oh wait, no. It's
There's
not,
12 cards.
but not all red are hearts. So.
Is there
So it
13?
can't happen because it's not mutually
It's not
13 hearts. There's 13 in each
Is it
suit.
independent
Yeah.
though?
Thank you.
Probability of the card being red. Probability of let's check. Let's do our math. Oh wait. It's 13 out of 52. So given B, given that the card is red. The card is red. Given what? Is it neither? Both?
A given, so the probability
Okay, so what do you think about mutually exclusive?
it's not mutually
Not mutually exclusive because we can pick a red heart, right? So it was red and heart. Okay, so not mutually exclusive. What about independent? So what's the probability of A happening? So A is a red card,
26 out of 52.
26 out of 52, so 1/2, right? Probability of A given B. So given that it's a heart,
So 13.
so how many hearts are there?
13.
13.
I don't get
Of those, there's 4 suits, right?
26.
So there's 52 cards, 4 suits in each card. There's the same number of cards in each suit. So it's 13 hearts, 13 clubs, 13 spades, 13 diamonds. Okay? So I have 13 hearts. Of those 13 hearts, how many of them are red? 13. All of them. Okay? So the probability of A doesn't equal the probability of A given B. So therefore not independent.
So neither.
So neither. Okay, one last little note about this. Yeah? One last little note. So 2 mutually exclusive events. So if we have mutually exclusive events, do you think they're sometimes, always, never independent?
Never.
Isabella says never.
Oh, I don't know if I'm right.
Repeat.
They're always
You have a minute and a half.
Thank you. So males can never be pregnant. Pregnant people can never be males. They're mutually exclusive.
That's true.
Okay, are these events independent? Does picking a man,
Yeah, they are.
Oh, never mind.
they're always independent.
Sorry.
sometimes, always, never?
Wait.
Sometimes.
Okay, let's think about it. Let's say male is A, B is pregnant. So the probability of A, does that equal the probability of A given B? What's probability of, okay, let's just, we have, whatever, probability of A is whatever it is. Let's say half of the people in the room are male. Okay, so let's say that's 1/2,
Uh-huh.
okay? Okay, given that I pick a male,
So
what's the no, sorry, I did it the wrong way. Given that I picked a pregnant person, what's the probability that I pick a man?
0.
0.
So not.
Okay? So, 2 mutually exclusive events can never be independent. Because if I pick males, then that's going to tell me something about the probability of picking a pregnant person. Okay? Oh, perfect. All right. So, I'll finish writing this. They just don't